everybody, and welcome to another nTier training video. I'm Lesley and this is section 4. In this section we're going to learn how to declare and initialize variables, cast variables, and create constants by using the final keyword. Let's get started. In section 2, we discussed some of the features of Java. You'll recall that one of these features is that Java is a strongly typed language. This means that every data point in Java gets a type. This can be a class or interface type, or it can be a primitive type, which is the topic of this lesson. Primitive data types can be integers, or they can be floating points. An integer is simply a whole number, and a floating point is going to be a number with a decimal. The first integer number is a byte. That is 8 bits. A short has 16 bits. An int is the default type and it has 32 bits. A long has 64 bits. Because the int is the default type, we'll need to cast that long. That means that we need to put a capital L at the end of each long data set. So you can also use a lowercase l, but that's going to get a little confusing because sometimes a lowercase l looks like a 1. So it's always best to use that capital L. We also have a float, which is 32 bits, and a double, which is 64 bits. Those are both floating point values. A double is going to be the default for a floating point. So if we do want to use a float, we're going to have to cast it to 1. This means that we have to use either a capital or a lowercase f at the end of our floating point number. Typically we use a floating point as a capital F, as we do along with a capital L. There are also char literals as a primitive data type. Those have 16 bits, and they're an actual letter instead of a number. Each letter has a Unicode value, as char is a superset of ASCII. So for example, a lowercase a equates to 97, while an uppercase A is going to be 65. The final primitive data type is a Boolean. This has a 1 bit, and it's going to have a value of true or false. Now, one thing we need to talk about with Booleans is that they have a specific naming convention. We want to form the name of a Boolean in the form of a question. So if you want to know if it's cold outside today, the way you might want to write that is cold. Now take a second to pause the video and fill this chart out for yourself. Here's the chart one more time, just to go back and double check your work. If you'd like to pause the video and check, now's a great time to do that. This chart represents how a computer sees a byte. The leftmost space, where it says sign, tells the computer whether the number is positive or negative. A 0 represents a positive number, a 1 represents a negative number. Therefore, we have 7 bits left for the value. So we are going to take -2 to the 7th power to get -128 for a byte. To get the maximum value, we take 2 to the 7th power minus 1. That gives us a value of 128 minus 1, and we get our maximum of 127. That's the range of values we have to put into a byte. If we put a value outside that range, the compiler is going to get mad at us and it's not going to work right. It's going to say, this is an error, fix it. And we can force it to cast down to a byte. We can say, hey compiler, I know what I'm talking about. I really want this to be a byte. But if we do that, there are some consequences. It'll flip the bits and it'll make it fit into a byte. So if we try to put 128 into a byte, it will flip it into be a -128. Therefore, it's best not to cast down to a byte if you don't actually want a number that's within the range of a byte. This is true for bytes, shorts, and longs as far as the calculation. Floats and doubles have much higher numbers and pretty much fit most anything in there. You can see the number breakdown on the screen here. And then we also have our booleans and our chars. One thing to notice is that \U0000 is the 0 value for a char number. So that is the minimum value for a char. A variable is simply a container that holds a value of a certain type. Variables must be declared before use in order to allocate memory, and their assignment happens from right to left. Let's take a look at an example. Along is our variable type. Our variable name is my number. You'll notice that this is in the style of camel case, so the very first word here is lowercase, and subsequent words will appear in uppercase. Together, these make up our variable declaration. Now we could end the line here by adding a semicolon and then assigning my number to a value later, or we can add an assignment operator here and assign it to the value of 23. Notice I have an L here, as this is a long value and it requires a cast. This is a simple way of declaring a variable. Now let's look at primitive versus reference variables. Primitive variables live only on the stack, while reference variables have a variable on the stack that references an object on the heap. A heap is going to be something that lives in a little bit more of a long-term memory, and in the stack, a variable goes away when it's no longer in use or needed. Let's code lab 4.1. So first you're going to want to open your text editor, whether you're using Notepad++ or Visual Studio Code, and create a new file. You'll save that file as primitives.java as a Java file, and then we'll create a class in that file called primitives. Open and close your curly braces, and then we'll create a main method. So the public static void main string array brackets args. Open and close your curly braces. And in this lab, I'm going to comment these in here. We want to create 8 variables using our new primitive types. We want to create an octal and a hexadecimal. And then we're going to print all of those out. So we're going to start with a byte. I'm going to call it my byte. You can name it whatever you want, as long as it follows the naming rules that you've learned about. We'll say that that equals 89. I'm going to create a long. My long equals 465L, because remember we have to cast a long. And we're going to create a short, and we'll call it my short. I've declared the variable, and on the next line I'm going to initialize that by assigning it to 45. Now you can choose any numbers that you'd like. I'm just choosing whatever number comes to my head first, really. Now we're going to create an octal. So we need an int type. We're going to call it my octal equals 0, because that indicates to the computer that this is base 8, as octals are. Being base 8, it means we have to choose a number to go next between 0 and 7. So I'm going to say 754. So as long as the numbers, the digits themselves are below 8, then you're going to be good to go on those numbers and you won't have any compiler errors. And then we're also going to create my hexadecimal. And it's going to start with 0x to indicate that it's a hexadecimal. Hexadecimals have a base of 16, which means that our basic number system of 0 to 9 for a base 10 is not enough. So we're using A through F on these, as well as your traditional 9. So we can say 7D, 8A3. Now let's print all of these numbers. You can continue to practice with, actually we'll add in a floating point here. So let's say double, my double equals 95.7. And we are going to print all of these out. If you'd like to pause the video here so that you can continue to add all the primitive variables that we talked about, you're more than welcome to do so. Please do, so that you get some practice in. And I do want to also add in here a boolean. Let's say is hot equals false. And I also want to take a look at the char. So my char 1 equals A, and we have to put that in single quotation marks in order for the compiler to read it correctly. And then we'll do my char 2, and I'm going to set this to a value of 65. We'll print these as well. And we'll save. And then we're going to head over to our compiler, and we are going to say Java C primitives.java, and then we'll say Java primitives to run that file. Now, a couple things I want to point out here. If you notice this number right here, that one was the hexadecimal. It was 0x7d8a3, and this is what it comes out to be in base 10. And then our octal was 0754, and it comes out to be 492. That char of 65 is an uppercase A, and then of course the literal A that we added in there is going to come out as a lowercase a as well. That's all for lab 4.1. In section 3, you took a look at some of the Java keywords. One of those keywords you saw was the word final. This is how you create a constant in Java. Using a final variable means that you cannot change the value of it at any point after you've created it. So let's try it out. We're going to create a file called Constants for Lab 4.2. It's going to be a public class called Constants. Make sure you open and close your curly braces. And then we're going to create a main method, public static void main, string array args, and then we're going to create a final double called pi, which is 3.14, a final double called Euler, which is 2.72, and a final int called my favorite number. And I'm going to make that one equal to 23. Let's save this and compile it just to make sure that it works. And see it compile. Now let's try to set pi equal to my favorite number. Save it. And now it doesn't compile. That's because we tried to take a final variable, which we said never can change, and tried to change it. So you can't do it, and we've proven it through code, which is pretty awesome that we can do that. Like I mentioned earlier, primitives are not the only way that we can give a variable a type. We can also use a class or an interface. One of those classes is the string class. Now a string is not a primitive, but it can be declared and assigned in the same way. We'll learn a little bit later on how it differs from other classes, as well as how to use the string's abilities a little bit more. However, we're going to take some time to intro those and declare some strings now. So strings hold word values. Let's go on and create a class called Intro to Strings. We'll give that a main method. And then we're going to create 3 different strings. So they're going to be capital S string. One of them is going to be my name. And we put strings in quotation marks. The next one is going to be favorite food. And I'm just going to say macaroni and cheese. And then we're going to do favorite color. And we're going to print all of those strings out. Let's save this file and go over to our compiler. It's called Intro to Strings. And then we're going to run the program. And you can see we print out my name, my favorite color, and my favorite food. In this video, I taught you how to declare and initialize variables, cast variables, and create constants by using the final keyword. We also talked about the string class. I'm Lesley, and this is nTier Training. Thanks for watching, and see you next time.